Hello, welcome to PhyzQuest. This question is about the solution of JEST 2019 Part A, question number 3. So the question is, consider the function f of xy is equal to modulus of x minus modulus of y. So we need to find out in which domain of the complex plane this function is analytic. 4 options are given. Basically we need to find out in which of the quadrant the function is analytic. So this question is based on mathematical physics, and the concept involved here is complex function, mainly complex analytical function. So first of all, what do you mean by analytic? Now you know that a complex function is said to be analytic if it is differentiable at every point of its domain. Now that means what? In simple term, the function has a derivative at every point of its domain. So how to check the analyticity? So to check the analyticity, or to check whether the function is analytic or not, we need to use the Cauchy-Riemann condition. So the conditions are, suppose there is a function f of z is equal to u plus iv. The complex function is said to be analytic when del u by del x is equal to del v by del y, and del u by del y is equal to minus of del v by del x. So these two conditions are Cauchy-Riemann condition. So whenever you need to check the analyticity of a complex function, you have to basically separate the real and the imaginary part, and the real part is the u and the imaginary part is the v. So then you have to carry out the process of this condition. So here in this question we are given a function fz is equal to modulus of x minus I modulus of y. Okay. So here first step is we have to differentiate the or separate the real part and the imaginary part. Real part is u and imaginary part is v. So here this is equal to u plus iv. So u is equal to modulus of x and v is equal to modulus of y minus modulus of y. So in order to test the analyticity, we have to use the Cauchy-Riemann condition. And Cauchy-Riemann conditions, as I already said, the conditions are del u by del x is equal to del v by del y, and del u by del y is equal to minus of del v by del x. So let us first check this condition, that is del u by del y, whether it is equal to minus of del v by del x. So if we check, here u is modulus of x, so del u by del of modulus of x by del y, obviously it will be equal to 0. Similarly, del of modulus of y with respect to del x is equal to again 0. That means both the condition, that is del u by del y is equal to 0, as well del v by del x is equal to 0. So this condition is satisfied for all possible qualities of modulus of x and modulus of y. The reason I first check the second condition, because here the purpose of this question is to find out whether, like, in which quadrant the condition, the function given is analytic. Now here in this second condition, if we apply, the terms goes to 0, so there is no need to check the quadrant. So first I have checked the second condition. So let's move to the first condition. So first condition is, for each quadrant we have to check. Now first condition is del u by del x is equal to del v by del y. This should be satisfied for a function to be analytic. Second condition is already satisfied for all the possibilities of modulus of x and modulus of y. Because when we check the quadrant, we have to choose the value of x and y there. That means modulus of x will be different for different quadrant, and similarly modulus of y will be different for different quadrant. So here we'll do that. For the previous case, it is already 0, so there is no need to check the quadrant there. So quadrant here means we have drawn this xy plot. So the first quadrant is here. Now here first quadrant is x is positive and y is positive. That is, x is greater than 0 and y is greater than 0. Now the given function is f of z is equal to modulus of x minus I modulus of y. So that means modulus of x will be equal to x and modulus of y will be equal to y. So function f of z is equal to x minus iy. Now if you put the first condition, then del u by del x is equal to 1 and del v by del y is equal to minus 1. So they are not matching. That means in the first quadrant, the analyticity is not satisfied. Let's check the second quadrant, where x is negative and y is positive here. So x less than 0 and y greater than 0 means modulus of x will be minus x and modulus of y will be y. So the function will be f of z is equal to minus x minus iy. Now check the condition. Del u by del x is equal to minus 1, del v by del y equal to minus 1. So they are matching. So in the second quadrant, the analyticity is satisfied. So then third quadrant, x is less than 0 and y is less than 0. Both are negative here. So here modulus of x will be minus x and modulus of y will be minus y. So the function will be f of z is equal to minus x plus iy. So here del u by del x is minus 1, del v by del y is 1. They are not matching, means in the third quadrant they are not analytic. The function is not analytic. So let's check the last, that is fourth quadrant. That is x is greater than 0 but y is less than 0. So mod x will be plus x and mod y will be minus y. So if the function will be f of z is x plus iy. So the Cauchy-Riemann condition, when we check, del v by del x is 1, del v by del y is also 1. So in the fourth quadrant, the condition is matching, that is satisfied. So as you can see, when we check the Cauchy-Riemann condition for the second condition is satisfied for all the quadrant, because it's all since both the values are 0, so there is no need to check the quadrant there. So we can say that the second condition is satisfied for all, but the first condition is satisfied only for the second and the fourth quadrant. That means the function is analytic, because for analyticity both the conditions should be satisfied. So which is applicable for the function in the second quadrant and the fourth quadrant. Now check the option. So we need to find out which domain of the complex plane the function is analytic. That is second and the fourth quadrant, that is option C. So option C is the correct answer for this question. Thank you.